I'm generally curious about measuring time versus measuring space. I mean, it's pretty clear, at least on an intuitive level, just what it is that I'm measuring when I measure like this, I guess the top of my laptop. But what is it that we're measuring when we're measuring time or watching a clock?
So let me just give you a surprising answer. Let's leave quantum mechanics aside now. Let's go back to relativity, okay? Oddly enough, in relativity, the length of the size of your laptop, that's really problematic. That's the hard part, right? What clocks measure according to relativity is you have this picture of, as you say, a space-time worm, right? That as it were you and the clock and any other kind of everyday item is this thing that kind of wiggles through space-time. And it always wiggles in a way that it doesn't go faster than light. So as we say, it threads the light cones. It's always kind of going up like this. And that path that the thing goes through has a length in relativity, a perfectly determinate, precise length, independent of reference frames, independent of any conventions, whatever, that's measured in a quantity called proper time. And what a clock, this is essentially the definition of an ideal clock in relativity. It's like a good odometer, right? What does a good odometer do? It accurately marks off distance that the car has traveled in space. A good clock is clicking off distance that it has traveled along its world line as measured in proper time. That's the relativistic answer.
And then I think this distance, though, immediately brings in the direction of time. And we have, intuitive, good prima facie evidence for there being a direction to time. And that, we remember the past and we don't remember the future. The immediate future tends to become the immediate past, and so on. But is there...
Pretty reliable tendency there, isn't it?
Quite reliable. It doesn't seem to go the other way. But is there a more precise way of describing what this means along the lines of the description you just gave for measuring time?
Well, you could look at different features that are associated with it. So, sometimes people talk about a causal asymmetry or an epistemic asymmetry, and then specifying carefully what those asymmetries are is a thing you can do. So, like the epistemic asymmetry is often glossed as, I know more about the past than the future, but that's not really all that precise, because it's not like anyone goes around counting the number of propositions that we know about the past versus the future. And so I think David Albert, nicely puts it where, it's more about the character of about the way we know about the past and the future. Because we can know about the future. I can take the present state of the universe, calculate out, when Halley's Comet will come next. And you could say, that I know that Halley's Comet is going to come, whatever date that is going to come. But, what I'm doing is I'm doing a lot of calculation, and I'm taking initial conditions and I'm evolving them forward with the laws. And it seems like I can just know stuff about the past in a different way. So you might characterize that asymmetry that way. So you have all these different types of asymmetries, and that's, so when we talk about the direction of time, it's really like a whole mess of different asymmetries.
Yeah, I would say among them, and again, everything I'm saying here, I always preface this is very controversial. A lot of people will, throw tomatoes at their screen when I say this. I would say, the fundamental one is causes precede their effects, right? So that's a heck of an asymmetry. That underlies a lot. And it underlies also explanatory asymmetries of everyday life. For example, you'd say, look, Someone asked, well, why is the Earth right where it is right now in the solar system? And if someone were to say, well, 10 months ago it was here, and then we've got the laws of gravity, and there were these forces on it, and it, then 10 months later it ends up here. Most people would say that's at least, that's a pretty decent explanation. I mean, you might worry about the thing going in. Nobody would think it was a good explanation to say, well, 10 months from now, it will be in such and such a place. And if I work backwards, which I can do, I'll find that given that 10 months from now, it'll be in such and such a place, it must be here now. Nobody would think that's an explanation, right? And nobody would say it's causation either. They wouldn't say the future state is causing its present location, but you would say the past location is part of the causes of the present location. And I don't think this is just a tendency, unlike, the reason why I want to bring this up is unlike epistemic axis, where you might kind of be weighing how much can I accurately tell you about the past versus how much can I accurately tell you about the future. And it's, it's a very uneven thing, but it's still, I think in the case of causation, it's just causes precede their effects, period, end of story, right? And so all of our other concepts that rely on causation inherit an asymmetry insofar as they make any reference to causation at all.
Yeah, so I think this is a place where Tim and I just differ, where I'm thinking that the physical asymmetries are what explain the causal asymmetry, that there's not maybe I should put it, the uncontroversial physical asymmetries are what ground the causal asymmetry. And that the causal asymmetry isn't sort of fundamental in some way. And I think, I have the intuitions that I do because I live in a universe such that there is this predominant direction of time given by by the processes in time. And that gives rise to me thinking of causation as this kind of really, fundamentally directed thing, but really, if the kind of arrows, if you drew the arrows so that there was backward causation, that would be okay with me. If the universe turned out to have systems like that.
So again, I seem to be making incorrect interpretations a lot of the time of what you two are saying, but that's good because then it just leads to clarification. But from what it's sounding like to me is that, Tim, for you, the direction of time is something maybe primitive about the way the universe is, and it depends on, it's just a product of causation. Whereas for you, Craig...
Other way around. Causation is defined, part of the definition of causation is that causes precede their effects. So it's not that the direction of time is causation, but that causation, right, in the definitory, by the way I understand it, the idea of backwards causation is, as it were, just impossible immediately.
By definition of what causation is.
Yeah, by definition of causation. You don't need causation to define that time as a direction. And you're right. My view is that directionality is a primitive and further inexplicable feature of it. It is the feature in terms of which one would go about explaining a lot of these other arrows or temporal asymmetries that Craig's talking about, right? So, look, there's clear temporal asymmetries. I mean, typically, if you had pictures of somebody with gray hair and a picture without them with gray hair, you could put them in correct temporal order, right? So there's an asymmetry in over a human life between the gray-haired periods and the non-gray-haired periods. But of course, that's not at all exceptionless, because dye your hair, right? Or maybe you take a pill that suddenly restores the color of your hair. I mean, there's nothing. This is just now a matter of statistics. And I think ultimately, of course, that's an actual asymmetry. It needs to be explained. And I think there will be causal explanations, but those causal explanations will already appeal to the directionality of time in identifying what's a cause and what's an effect. So that's the way I go about this. And sitting at the bottom, there is fundamental.
Yeah, so my positions of that flipped, so I'm trying to then explain this causal arrow from a bunch of other arrows I get in physics and the other sciences. And so that's a kind of divide. So I think, I don't really have a horse in this race exactly, but in my gut, I think, I've already got a lot of arrows, and let me see what I can do with them. And so if we could explain using a bunch of different arrows that are in physics, the causal arrow and the knowledge arrow and all of that, then that would be fantastic. So I don't want to jump to just that it's primitive. So for me, that's always a kind of position of last resort. And so I don't know that it's not primitive. So I don't know that Tim's view is false. To me, it's open question, but I would rather at least try to come up with a theory with a bunch of existing arrows to explain the other arrows. I don't know if that was clear at all.
No, that's totally clear. It sounds kind of like the parallel postulate in mathematics. I mean, people want to get away with the fewest amount of primitives and axioms that they need. And it's something similar here. You would like time to be determined by the laws of physics in the way that something like, I don't know, maybe gravity is, as opposed to taking it as primitive itself.
Yeah, that's right. So try to do more with less.
And is this sort of disagreement between you two, how would it be adjudicated? Is it something that experiment could confirm or disconfirm way one or the other? Or how do you get past this sort of, I don't know, maybe this is intractable and it's just going to be a matter of taste?
This is really like a more joke but we take a time reverse person and ask them if they're conscious, and then that would adjudicate the question between Tim and I.
Yeah. I don't think experiment is, unless, look, my view, because of what I just said, has the consequence, unless you do something really screwy, that there can't be causal loops, there can't be backward causation, stuff like that, right? Because causes always precede their effects, and in a normal space-time, that you never go around, right? Now, if one could imagine if there were such a thing as backward causation or circular causation or something like that, that would put very strong constraints or allow really otherwise weird things to happen, or demand maybe that otherwise extremely strange and what would seem to be inexplicable things happen. And so if somebody said, yeah, I have a theory of time, and furthermore, I'm going to allow backward causation, or I'm going to allow these loops, and furthermore, I think we can set up in a lab a situation that will have these things. My guess is, at least for many of these, they would predict things that I wouldn't be able to predict. I really wouldn't be able to explain them, because, that would put these monstrous constraints on things that I don't have. So that could certainly be indirect evidence, right, of the normal kind. We say, gee, theory A, here's an actual phenomenon in the lab. Theory A handles it easily. Theory B doesn't handle it easily or at all. That's some reason to believe theory A. But I don't know of anything on offer of that sort.
Yeah, for me, it's definitely not thinking about closed time-like curves and time travel or any of that. It's more the sort of explanatory challenge. So, can I get the knowledge asymmetry from the thermodynamic arrow? That is not easy. So that you have a well-defined thermodynamic arrow, everyone agrees that this exists and is a thing. But as I think it was Jas Hufvik said, if you put a person in a refrigerator, they don't start remembering the future. And so it's very, so it's not so easy to get the, so if you want to go from the thermodynamic arrow to the knowledge asymmetry part of the direction of time, it's not so easy. David Albert has a massive program trying to do this. Before that, Reichenbach. But anyway, it's not easy. You could then try to do something similar also for the causal arrow, counterfactual arrow, explanatory arrow. It's not easy, but part of it not being easy makes it a kind of fun challenge. And if you were successful, then that would be, I think quite an achievement.
Yeah. I mean, and I should say, look, the first thing that Craig talked about, we talk about temporal arrows just meaning that there are at least statistically temporal asymmetries, right? Statistically, many more people have their gray-haired period of life later than their non-gray-haired period of life, right? That's just a fact. You could have a baby born with gray hair that later, it might not be universal, but it's certainly a manifest statistical asymmetry. And there are these asymmetries of knowledge and these other asymmetries. There are thermodynamic asymmetries and entropic asymmetries and so on. On my view as well, it's not like having a primitive direction of time just magically explains all these. It doesn't. And there's a question of whether some of them are deeply connected to others of them. And it would be interesting to find out. Certainly, it would be interesting for someone to give an argument. I mean, just take the one I gave. Is there any connection between having gray hair generally in the later years of life and entropy? I kind of doubt it, because I don't think that there's gray hair is more entropic than non-gray hair. I kind of doubt there's a connection there. I think it's probably more an accident in genes and various things. But sure, there are lots of these asymmetries, and to the extent that you can explain one or anyway, connect one to another, you're getting understanding, and it's a worthwhile project. And you should certainly push it to see how far you can do it. But that, taking my position about there being a fundamental direction of time doesn't foreclose that at all.
No, but I would like to see more, maybe I just want a more nuts and bolts picture. Well, I'll tell a little story, which maybe I've said to Tim before, or maybe not. Anyway, you'll find it amusing, I think. So where I went to graduate school was with Tim, and so I was taught by Tim, but also a mutual friend and colleague, Bob Weingart. And so he had a theory a little bit like this, where he said, in general relativity, people often talk about time-orientable space-times. He says, well, let's just actually orient it and put in a kind of vector field all over the space-time pointing to the future. And so what this means sort of intuitively is, well, space-time is orientable, if temporally orientable, if you could sort of consistently color, say, the future lake cone, like red. I've got a diagram, I just consistently color it red everywhere. But now let's have an actual field on there that points to the future everywhere. And then the thought was, charge, which way will it radiate? It would consult the vector field, and so a charge could be advanced or retarded. It would consult that and then decide, well, I'll be a retarded radiation. And I said to Bob, yeah, but what is this consulting? How does it actually happen? He said, well, he saw a paper in a Japanese physics journal, which gave a kind of mechanism for how this would happen. But he said he couldn't find the paper again. And my thought was, well, until you find that paper, I'm not really going to see how this vector field does any work.
But I'm going to turn on the light because they aren't here. Let me actually make a comment. I mean, I don't remember ever hearing that story. It's an interesting story, but it actually does, I think, indicate what I had in mind, and I think Craig would agree. So one of the asymmetries people talk about is this radiative asymmetry. So they say, look, build a big radio tower, and you can drive electrons up and down it, and then you get these radio waves that radiate out kind of spherically from the tower. Yes? That happens all the time. Easy to do. People do it all the time, and they send out radio signals that way. Send music. The physics allows, as a possible physical solution, the time reverse, in the sense of, instead of radio waves going out from the tower, they could be collapsing into the tower. And when they get there, they would then drive a big current up and down the tower. But we never see that, right? That's true, right? We see the one all the time. We don't see the other ever. And people have said, well, why is that? Because they're both allowed by the laws of physics. Now, there's something a little funny about thinking you have to explain why something allowed by the laws of physics doesn't happen. I mean, it's allowed by the laws of physics that I win the lottery, but it never happens. I mean, does that need an explanation? Anyway, but some people have said, I think quite correctly, this can be assimilated to entropic issues, that somehow to send in a coherent collapsing wave, you'd need the emitters of that, which would be all around, way out here, very carefully tuned and organized to send the wave out from all these different locations at exactly the right time and exactly the right amount so that it collapses into the tower. But sending the wave out doesn't require that. You just turn on the thing at the center, right? It does this, does that. So there seem to be connections between entropy, various entropic or thermodynamic asymmetries, and the radiative asymmetry. And I think you make progress by seeing those connections and saying, yeah, it looks like this asymmetry at base, if it's not literally the other one, it's kind of on the same basis as the other one. I think that's really good work. But notice the way I even stated the problem presumes there's a direction of time, because I said, look, all the time you see this and you never see that, but the only difference between this and that is the direction of time, right? It's in the one case, the earlier time is with all the radio waves right by the tower, and the later time is them far away. And in the other one, the earlier time is all the radio waves far away, and the later time is them all collapsing into the tower, or the difference between going in and coming out. That is the direction of time. So I kind of presume the direction of time to even state the puzzle, which suggests that it shouldn't be taken as bringing the direction of time itself into question. But there is an asymmetry there. There sure is. And we ought to try and understand it.